Hello and welcome back, everybody. In today's class, we're going to be talking about a very both controversial and interesting topic, and that's the field of behaviorism. In particular, we're going to be talking about two branches of behaviorism, both classical and operant conditioning. In this discussion in the field of behaviorism, what we're going to be doing is trying to outline both what behaviorists do and then some of the major behaviors that we've encountered over the years. Now, when we talk about behaviorism, we have to mention something that we don't usually have to mention in most classes. And that's the fact that this particular field, this branch of psychology, is one that tends to be mired in controversy. And that's because behaviorists usually operate under the assumption that we can explain a lot of human nature, a lot of the world around us, by whittling things down to just simple forms of interactions between individuals and their environment. Namely, who you are, behaviorist believes, is almost entirely a product of the things that you've encountered along the way. Lots of people are sometimes bothered by this. Lots of people tend to disagree with some of the major stretches that behaviorists make. But I need you to keep in mind, as we talked about in the history of psychology class, that even if you don't necessarily agree with everything behaviorists might argue, there's a lot of research behind this particular theory and this particular field. And even though it might rub people wrong, there seems to be a lot of supporting evidence for some of the statements that some of these researchers are making. And more importantly, even if they're wrong, this particular area, if you're learning about psychology, is one that you must understand, you must appreciate, because it was the dominant theory, the dominant area for people to study in this field for over 50 years. And because of that, we are going to be addressing this field despite the fact that behaviorism has almost entirely disappeared from the field of psychology, except for a few individuals that are still studying some of the principles of learning that behaviorists study. But before we get into the current stuff, major theories, we first need to define what behaviorism is all about. When we're talking about behaviorism, what we're talking about is an approach to psychology that involves simply looking at the observable. Namely, we assume that every behavior that's being exhibited, every reaction that somebody produces, is a product of an observable cause and effect relationship. We don't have to look into your feelings, your emotions, your thoughts, your memories to figure out why you're doing things, according to behaviorists. We just have to look at the surrounding environment, the stimuli that you recognized and made sense of, in order to predict what you're going to do from a moment-to-moment basis. Now, this assumption is one of the things that really bothers people because it kind of discounts the idea of free will, or this notion that what you're doing is somehow a product of your own thoughts or your own internal desires. Behaviorists argue that if we look at all of your past experiences, your memories, your, learned encounters, what we can do is theoretically figure out what you're going to do from a moment-to-moment basis. But there are some behaviorists that don't necessarily think we might be able to explain everything, but instead say if we're going to try to talk about psychological terms, talking about what we feel, how the mind works, is going to get us into some very dirty areas. In essence, we're not going to be able to be sure that what we're using to explain something is legitimately happening. If I say, I'm doing something because I'm happy, well, how do I know you're truly happy? How do I know that's why you're doing something? So what most behaviorists do, regardless of whether or not they think they can explain all behavior through this cause and effect relationship, is look for environmental stimuli that are changing environments. And by looking for those environmental stimuli, behaviorists have come up with a number of terms and a number of connections that we've made over the years to explain human behavior and how we act, and obviously they've extended this to animal behavior as well. When we talk about the area of behaviorism, really give you a sense of how behaviorists can stretch their understanding of the human mind. What we have to do is introduce one really polarizing figure. His name was John Watson. Most people consider Watson the father of behaviorism. And that's because even though he didn't really introduce any major theories, at least no terms that really were earth shattering in the field of behaviorism, he's very well known in this particular branch because he was the one that pushed the notion that behaviorism not only could explain most of our behavior, but theoretically could explain every single subtle nuance to us. In his mind, who you were, everything that made you somebody, including himself, was entirely a product of the different stimuli that we've encountered throughout our entire lives. His most famous statement he made, which is listed on this slide, is give me a dozen healthy infants, well formed in my own specified world to bring them up in, and I'll guarantee to take anyone at random and train him or her to become any type of specialist I might select. What that implies is that if you have absolute control over the environment, over every stimulus that somebody encounters, and everything that they see or hear or touch, then theoretically you can produce a person in any way, shape, or form. You can create a person that loves to, knit, or somebody that's obsessed with sports, or somebody that's very good at ping pong. Whatever it is, you can create it based on really having absolute control over the environment. Now, Watson knew that he couldn't be certain to control somebody's environment. It'd be very unethical to even try it. But this was this stretch of behaviorism that he believed in. That you didn't have thoughts or emotions or even biological predispositions that pushed you in certain directions. Instead, you were simply a product of what you'd encountered throughout your life. Not only did he try to push this in his debates, in his speeches, but he also tried to prove it. And this is something that got Watson in a lot of hot water. In particular, he tried to prove it with a very special child that we've now come to know as baby Albert. Albert is probably the most famous research experiment of or research participant of all time. Probably better than Ebbinghaus or Piaget's three kids, Jacqueline, Luciente, and Laurine. And that's because little baby Albert was used by Watson to prove the scope of how effectual behaviorism can be. The story of little baby Albert is quite possibly as interesting, though, as the implications behind what Watson found with it. Now, Watson, after making the statement, as we mentioned before, had decided probably before that he wanted to not only make these statements, but prove them to be true. So what Watson decided to do was take advantage of one of his research assistants that had access to one of the hospitals near his school. And this research assistant worked in a very specific part of this hospital named the Infant Care Unit, where children suffering from lifelong diseases or major problems at birth were administered treatments and sometimes just kind of put in these areas as they either recovered or kind of whittled away in their lives. And this access to these children was something that Watson was very interested in because he saw it as a chance to get at people that hadn't had much exposure to outside stimuli in their life. So what Watson did was convince Rayner to allow him to go into this infant care unit and test out some of the kids. So he would have them pulled into a separate room and present them with a bunch of different stimuli, things that the children could play with or just look at and see. And what he was looking for was a child that was not scared of anything, really didn't display any emotional reactions to anything to anything in the environment. And after testing a large number of kids, the one that he settled on, the one that he came across, which didn't display any sense of fear, was this child named little baby Albert, or at least he later called little baby Albert. Albert seemed to really not be fazed by anything. He wasn't upset or startled when something new was in the environment. There wasn't one particular item that he was exceptionally scared of. After discovering little baby Albert, Watson decided that this was the child he was going to do his really groundbreaking experiment on. So after deciding on Albert, he let him go back to his room, and the next day he went in, grabbed Albert, and again put him into this experimental room, where he then proceeded to expose Albert to a number of stimuli. After a while, he brought in a very special stimulus, namely a tiny white rabbit. Now, some people say it was a white rat, others say it was a white rabbit. We're going to go with rabbit today, just to be safe. And this animal that he brought in was not something that produced any specific response from Albert to begin with. In fact, Albert, like most children who aren't scared of animals, tried to approach it. He tried to grab at the rabbit and try to play with it. And this, to Watson, was perfect because that's what he was looking for. He was looking for a child that showed no fear of this white rabbit to begin with. As Albert was playing with the rabbit, though, what Watson then did was sneak up behind him. Sneak up behind him in a way that Albert wasn't allowed to see him or wasn't capable of seeing him. And then behind Albert's head, as he was playing with this little white rabbit, Watson took two pans and banged them against each other really loudly. And for anybody, this natural reaction is to be startled, to be scared. And any child that you do this to will naturally cry, which is exactly what Watson was expecting. And lo and behold, when he banged these two pans behind Albert's head, the child began to cry, began to sob uncontrollably. It was perfect for Watson, because after the child began to cry, he quickly grabbed the white rabbit, ran out of the room, moved out of the room himself, and then after the child had calmed down, his research assistant, Rosalie Rayner, took Albert and put him back in the infant care unit. Next day, Watson again grabbed Albert, brought him into the infant care unit, let him play with a number of toys, and after a while, again, he allowed that white rabbit to go into the room. And after playing with the white rabbit for a while, again, Watson snuck up behind and bang! Loud pots behind his head. Albert began crying. Watson left. Rayner came in after he stopped crying and brought him back to the infant care unit. And the third day, they proceeded to do the exact same thing. But by the third day, Albert started catching on. When the little white rabbit came out, he started looking a little scared, a little concerned. And eventually, when Watson banged the pots and pans, Albert was crying uncontrollably within a matter of a tenth or a hundredth of a second after the pots and pans had been banged, because he was expecting it. He was ready for it. And the fourth day, when Watson tried to repeat this, Albert was already crying by the time the little white rabbit had come out. And by the fifth time, just the sight of the little white rabbit was enough to make little baby Albert cry. This really excited Watson. So then what he started doing was testing other things. So he'd bring in a little white rat, hence the reason why rabbits and rats often get mixed up, because it was one or the other the second time. And this second animal that would come in produced the exact same fear response. Then he tested fur coats, and again, little baby Albert began to cry. Essentially what Watson showed is by having this small amount of exposure to a really loud bang and something white and furry, he could create a nasty, extreme fear response in a child that had never displayed it before. This, Watson thought, was the basis of human behavior. What we're scared of is simply the product of what we've had adverse reactions to in the past. He was very excited about then showing that what we can do is theoretically remove that just as easily if we untrain it. But when he started trying to do this with little baby Albert, he ran into a bit of a problem. And that's the fact that, as the story goes, little baby Albert's mother caught on to what was going on. She found out what Watson was doing in these experiments, and as a normal mother would be, she was infuriated by this. And again, this is simply more of a story than something we have scientific proof of. So the story goes, she promptly took little baby Albert out of that infant care unit, filed a report, and then left the hospital, and little baby Albert was never theoretically heard from again. So there were stories for many years within the behavioral field of a young child, and a teenager, then a grown man, and now he would be in his, I think, 70s or 80s, uh, running around terrified of little white rats. Odds are fairly good. Little baby Albert actually didn't make it because he was indeed a very sick child when Watson was doing these experiments on him. In fact, some research has shown that little baby Albert didn't make it past the age of, I believe it was 3. But if little baby Albert is still out there, it makes for a very enticing story. And it makes really this idea of behaviorism truly take hold. Because what it tells us is that indeed human beings can be transformed very dramatically just by a few small encounters, especially if those encounters are strong enough. This idea of exposing little baby Albert to stimuli is just one of many ideas that behaviorists have come up with over the years. And when we talk about behaviorism, what we're talking about is in essence the idea of learning. Who we are, what we do, is theoretically, according to behaviorists, just a product of what we've learned. And what we learn can typically be whittled down into just one of two things. Well, actually, two different things. The first thing that we can learn is how things are connected. This particular idea or this particular concept relates to that idea, or that this particular stimulus indicates that this is going to happen. So you go to a soda machine. You know, if you push a specific button, it indicates that that button is paired up with you getting a specific type of soda. If you see a red light, you know that that red light indicates when you're driving that you need to stop your car. This idea of connections, learning how things are together, is, according to most behaviorists, absolutely essential in our forming of behavior and our forming of understanding of how the world works. Another type of learning that has to occur, though, is one based on consequences. So if I do this, in particular in these situations, this outcome will actually occur. So not only do you have to learn that a button on a soda machine is associated with a specific type of soda, but you also have to learn that you have to push that button if you want that soda. And then if you push that button and you put in the right money, your soda will emerge. Very often these two types of learnings are paired together, but behaviorists have actually for many years studied these two types of learning separately. And that's what we're going to be discussing in today's class. Learning by pairing and learning by consequence. In this first half, we're going to be focusing on the learning by pairing. When we talk about learning by pairing, we have to introduce the founder of the field of behaviorism, really the person that got this research rolling. And that particular individual is named Ivan Pavlov. What's really interesting to a lot of psychologists is the fact that even though he really was the figure to get this particular branch of psychology moving, he abhorred psychology for a very long period of his life. In fact, when he was going in through graduate school, he had made a number of comments and published a number of things to imply that psychology just wasn't a science at all. It was more of what he called a pseudoscience. And what he was really obsessed with for a very long period of time was biology. In fact, I believe, if I recall correctly, he earned his dissertation by looking at our circulatory system, so how blood flowed to and from the heart. And in his work, he eventually stumbled upon a specific research topic on saliva. Namely, he wanted to see how saliva, how much we produced in different situations, was related to the amount of food that we were presented. His subjects in his experiments were a collection of dogs that he had essentially created a very specialized apparatus for. What this apparatus was a test tube, or a series of test tubes that he actually hooked up to the salivary glands of these dogs. And what he wanted to do was expose the dogs to varying amounts of food to determine if those varying amounts of food changed the amount that these dogs salivated. In the beginning, this experiment was going very well. They bring in a bowl of food, they'd have the test tubes hooked up to the dog, and he'd see how much the dogs would salivate as they were about to eat the food. But as these tests started to develop, he ran into a bit of an issue. Namely, the dogs started screwing up his data. As the research assistants would come towards the dogs with the food, even before they could see the food, eventually, as they'd learn to make connections, the dogs would start to salivate. And this was a major problem for Pavlov. If he was trying to use the amount of visual information they were getting to predict how much they were going to salivate, it didn't help if they were salivating before they even knew how much food they were getting. So he started trying to fix this. He started trying to have the researcher come in, not carrying the bowl, but only walk in with the bowl hidden behind their back, and then quickly throw the food down. But eventually, the dog started associating just the research assistant with the food. And he'd lock them in rooms and have this research assistant try to come from one end of the room to the other without being seen and slip the food underneath a door that the dogs were in. But soon the dogs would start associating the footprints of the researcher with the food. Then he started trying to create a way where the research assistant wouldn't even be heard by muffling the sounds that the research assistant was making. But soon the dogs would associate just the turning on of lights, or the click of a light switch, as indication that they were going to get food, and they would start salivating early on. This problem, this effect, was something that infuriated Pavlov when he ran into it. Because essentially, he had no way of measuring what he was interested in these conditions. So he was stuck at an impasse. He had to either figure out some really ingenious way of not allowing the dogs to have any indication that they were going to be fed, or he had to study this really peculiar behavior that nobody had an explanation for. This was very painful for Pavlov to make this decision, because by doing it, he knew that he had to get into a field that he absolutely abhorred or hated. And that was the field of psychology. Fortunately for us, though, after thinking very long and hard, he decided to actually explore what he later called psychic salivations of the dogs. The salivary response to all of the different stimuli that the dogs had encountered. For this, he eventually went on to win the Nobel Prize, and more importantly, formed the basis of a major branch of psychology that we've now come to know as classical psychology. I apologize. I meant classical conditioning, not classical psychology. Classical conditioning is the first type of learning that we study within the field of behaviorism. It's based on the premise, again, that what I'm doing is probably highly motivated by how I've learned to actually associate things. In Pavlov's mind, this form of learning is just a very simple connection that we make along the way in our lives. He said to start classical learning, what we need is what he later called an unconditional reflex. And this unconditional reflex involves two things: an unconditional stimulus and an unconditional response. Now, later he went on to call these unconditional stimulus and unconditional response an unconditioned stimulus and an unconditioned response, or a US and a UR. He said this reflex was just simply a basic response to a stimulus that required no learning. So if I give you food, your body's predispositioned to salivate. If I don't know, slap you, or let's say shock you, let's go when it's a little bit easier to use, you'll recoil naturally. It's not going to take learning to learn, you need to jump back when you get shocked. Well, according to Pavlov, in our lives, we have a number of different unconditional reflexes that require no learning whatsoever. But what he also thought is that we can start to display these unconditional responses to other stimuli if the conditions are correct, if we introduce the right information. This right information he later went on to call a neutral stimulus. What he was trying to do, in essence, was show that if I introduced something that produced no response to begin with, or was neutral, and pair that stimulus with what's originally an unconditioned stimulus, something that produces an automatic response, after multiple pairings, eventually the organism can learn that that neutral stimulus is indicative of the unconditional stimulus. So in Pavlov's experiments, in the very beginning, what the dogs were doing was just reacting to the food. The unconditional stimulus was the food, the unconditional response was the salivation. But eventually they started realizing that the research assistant was actually always indicating that the food was going to come. So eventually, what the dog started doing was not reacting to the unconditional stimulus of the food, but reacting to the neutral stimulus, something that never produced a response initially, of the research assistant. And this pairing produced two new stimuli that Pavlov was very interested in. He called this a conditional reflex. The conditional reflex involved both the conditioned response and the conditioned stimulus. The conditioned stimulus was merely now this neutral stimulus. So in his original study, the research assistants became the conditioned stimulus. And the conditioned response was the exact same as the unconditioned response, but instead of it being to the unconditioned stimulus, the conditioned response was the response to the now conditioned stimulus. So for Pavlov, it was salivation to the research assistant that became the conditioned response. This particular idea of classical conditioning, the very basic formula of talking about what happened before training, what happened during training, and what happened after training, has been the basis of a lot of discussion within the field of behaviorism for many, many decades. This simple formula has been used to explain a number of different, very elaborate behaviors that we've exhibited over the years. Very rarely do we find any evidence that allows us to say that learning does not take place in just this basic form. And by using this idea to apply to development, to learning, to social behavior, we've been able to use the tools of behaviorism to explain a lot of things. Unfortunately, as simple as this idea is, it can sometimes get lost in a lot of students. In fact, if I'm going to suggest studying up on something, coming up with examples for something for this next test out of everything that we've talked about, I would say spend considerable time on this particular topic, because for some odd reason, even though it makes sense in writing, or makes sense as I'm talking here, when I give you a hypothetical situation, many students for some reason struggle with how to identify what's a neutral stimulus, what's an unconditioned stimulus, what's a conditioned response, and all the other things that we see here on this formula. But there's more to this than even just that basic formula, and this is all stuff that Pavlov discovered after coming up with this idea of classical conditioning. In addition to talking about how classical conditioning works, Pavlov later went on to introduce something he called a learning curve. This learning curve involved the percentage of the time that conditioned response was produced based on what was originally the neutral stimulus. So in the beginning, when a neutral stimulus was first paired with the unconditioned stimulus, the learning curve would indicate that 0% of the time would that neutral stimulus produce a conditioned response. But after repeated exposures, more and more often, you not only get more commonly a conditioned response, but the conditioned response would be stronger and stronger. So Pavlov's dogs, in the beginning, only every now and then would the dogs salivate to the research assistant. And when they salivated, their salivation was much less than what it was as these experiments progressed. By the end, when the dogs had actually learned that that research assistant was paired with the food, not only did the dogs salivate 100% of the time, but their salivation was exceptionally strong. This was what Pavlov wanted to represent in his curve. And as this curve went up, what he was also interested in doing was understanding what happened once it got to its peak. And this involved breaking or severing the tie between that unconditioned stimulus and the conditioned stimulus, or the thing that had now become a conditioned stimulus. What he was interested in seeing was not only how fast something could be acquired, but how quickly that thing that had been acquired could now then be lost. And once he severed that relationship, what he wanted to see, in essence, was how quickly that conditioned response could become, well, a response to what eventually would become, again, a neutral stimulus. So a conditioned stimulus transferring back into a neutral stimulus. He spent many, many years studying this learning and forgetting curve. And what he produced was something like the information you see on the next slide. Notice the slow, gradual incline that he called acquisition or learning, and the sharp decline, something he called extinction or forgetting. I also want you to notice, though, that there's some more to this formula that he discovered later on. And this relates to something he called spontaneous recovery. Namely, what he found, and you'll see that information in the last slide, is that if something's been forgotten, if, of course, first you need classical conditioning to occur, and then something's been forgotten, you can actually create a situation that produces a new learned response without having to retrain that information. What he found with his dogs is if they were exposed to that research assistant over and over again, and they learned that that research assistant was associated with food, and then the research assistant stopped being associated with food, if you could have these dogs, separated from the research assistant for an extended period of time, not have them encounter this research assistant for many days or weeks, then he re-exposed these dogs to the research assistant, something funny happened. Even though they'd learned that the research assistant originally was no longer paired with the food, temporarily, in that reintroduction period, they would respond as if, again, this research assistant was back to being paired with the food. It didn't last a long time. There's a quick forgetting curve to this as well. But indeed, this idea of spontaneous recovery was something he found time and time again in his experiments, and something other behaviorists have replicated over and over again. But there's even more than just this when we talk about the idea of classical conditioning. Since this work was done by Pavlov, other researchers, and this is one of the big important impacts that Pavlov had, decided to add to his formula, to add to his research and come up with their own terminology and ideas of how this concept of classical conditioning could be improved upon or altered in some way. One of the things the researchers have looked at is how classical conditioning can be made more or less effective by changing the basic scenario that Pavlov had introduced. One set of researchers over the years had looked at the idea of what happens when we change the characteristics of the neutral stimulus. And in numerous studies, what we've seen is that there are specific neutral stimuli that can be more, responded to, or at least responded to more easily, learned into becoming a conditioned stimulus more easily. But more often than not, when we're talking about when a neutral stimulus can become a conditioned stimulus more quickly, the most important characteristic to that neutral stimulus is the fact that the neutral stimulus has to be novel, or something we haven't encountered before. An example of this would be, say, a bell. If you've heard a bell 100 times before, that exact same bell, and we start pairing that bell with, say, food, the odds are that it'll take you a really long time to learn that that bell is indicating food. And if you had never heard the bell before, at least before you started learning that that bell was paired up with food. Another thing that we found when we talk about this idea of classical conditioning is that the time between when the neutral stimulus and the unconditioned stimulus is presented is really, really critical in how quickly we acquire information. If I present a neutral stimulus and then present the unconditioned stimulus, well, I guess the neutral stimulus, as you see there on the slide, is called a conditioned stimulus with time, but if I present that neutral stimulus to begin with, and then have a huge amount of time pass between then and when the unconditioned stimulus happens, that information usually takes a long time to acquire. But if I introduce a neutral stimulus, or what's eventually again called a conditioned stimulus, and have it followed almost immediately by that unconditioned stimulus, then the odds are fairly good that you'll acquire that conditioned reflex, or the conditioned response, much, much more quickly. Another thing that we've seen is that you can also change not only the timing between the neutral stimulus, or the conditioned stimulus, and the unconditioned stimulus, but you can also change the sequence or the order of that neutral stimulus unconditioned stimulus pairing. What we see in numerous studies is that when I want to create a quick link, I want to make sure that the conditioned stimulus is presented before the unconditioned stimulus. We call this forward conditioning. Theoretically, you can do something called backward conditioning. So I could present the unconditioned stimulus and then the conditioned stimulus, or it's originally the neutral stimulus, afterward. So if I was the researcher in Pavlov's lab, I might give the dog food and then pop out so the dog sees me while it's eating the food. I give the dog food and pop out so the dog sees me while I'm giving it food. And if that's what's happening over and over again, eventually I could theoretically just come into the room and the dog will start salivating when it sees me, even though the food's always preceded me in the past. It does work, this form of what's called backward conditioning, but in all reality, what we see time and time again is that forward conditioning is by far the best way to create a learning situation or a learned behavior, or this best method of creating a learned behavior. Another thing that we've seen over years, which sometimes bothers behaviorists because it forces us to go into the field of biology, is that there are very dramatic differences between species with different types of learning. Some species seem to have an innate ability to create some learned connections while not creating others. A classic example of this is actually rats and food. What we've seen in numerous studies is that rats seem to be kind of the best tasters in the world. Not that they have an exceptionally diverse palate, so they only appreciate really good food. Instead, they can distinguish between different tastes really, really well. So in research studies where rats are given small amounts of poison in anything that they eat, what we found is that those rats will associate that taste of the food that they're given with sickness instantly. Essentially, they will avoid that flavor for the rest of their lives because of the sickness that they acquired. In essence, the sick reaction is something that they're innately, I guess, inclined to look for. And those tastes that they detect, they have some sense that other species just don't have. In fact, if any of you own dogs, or if any of you have family members that are just extremely stubborn, you've seen many other animals encounter foods that make them sick over and over again, and yet they still do not learn that that particular taste is associated with getting sick. In essence, they don't have that conditioned response to the food, or that aversion to the food that we would expect if classical conditioning was happening very quickly. But I digress. When we look at this idea of classical conditioning, what I want you to get a sense of is that since Pavlov's work, we've built on it. We've added things. We've created our own set of terms and ideas that we now apply to the basic concept of classical conditioning. Two final terms that you really need to know when we talk about classical conditioning are the terms generalization and discrimination. It's because Pavlov and other researchers after him came to believe that when we're talking about pairing of stimuli, it's not just one particular stimulus that automatically produces exactly one response, but instead what we operate on is something he called gradients. So if a stimulus is similar enough to something that's become a conditioned stimulus, then that new stimulus, which may have never been presented before, can actually produce a similar conditioned response. So in Pavlov's case, what he could do is present one research assistant over and over and over again with food, and eventually that dog will salivate to that research assistant. But sometimes he could bring in a different research assistant. And if that research assistant that the dog had never seen before was similar enough to the one that the dog encountered on a regular basis, then the dog would again salivate like this new person was the exact same as the original research assistant that they had seen over and over again. In essence, these dogs would be doing something that Pavlov called generalization. However, theoretically, these dogs could also what's called discriminate. So they see this new person coming in, doesn't look similar enough to the original one, and therefore they do not salivate. Essentially, they react to this person, this new person, as if they're a neutral stimulus. Now, this can happen because of degrees of overlap, percentage of overlap between this new stimulus and the original neutral stimulus that became a conditioned stimulus, or this is something he also learned, you can actually train it into people. So you can actually train individuals or other species to become more discriminatory. And this involves something called CS plus and CS minus, where we train somebody to distinguish what's going to get a reward and what's not going to get a reward. We are not in a behaviorism class. You do not have to memorize those CS plus and CS minus terminology. But I do want you to at least get a sense that discrimination and generalization can happen naturally or through learned encounters that encourage generalizing or discriminating in different situations. These ideas and terminology that we've introduced so far has put us through about the halfway point in this idea of behaviorism. But, as was mentioned earlier, we still have another major area of behaviorism to talk about. We've learned about associative learning, how we pair things together. We still have to learn about consequence-based learning. When I do something, this will happen. To discuss consequence learning, we have to reintroduce, well, actually, we have to introduce, not reintroduce, two new figures, two new big people in the field of behaviorism. But before we get to that, I want to have us take a break here so you can recollect your thoughts. Be ready to go when we talk about the next area of learning called operant conditioning. So please, read if you have to, otherwise take a break, and we will continue on with this area of operant conditioning after the break.